Today I'm going to be talking about building a C2 and why it's a great project for pretty much everybody to try at some point. My name's Jim. I graduated last December. In my time at RIT, I did a lot of red team stuff. I was the chief for a little bit, lots of Linux things, logs, infrastructure, that sort of thing. And now I work at Expel as a security analyst. So basically, the general reason for this talk is that a lot of upperclassmen, and myself included when I was a student, are always saying, write a project, work in the labs, et cetera, et cetera. Like, we're pretty much just telling you to try and learn how to grind. And that's a really daunting task if you haven't really done a personal coding project before, um, especially if you're new to security and you have no idea what you even want to go after. It's a super broad field. So if you've been around the community for a while also, and maybe you've messed around with a few things, maybe you're an advanced dev or you have a crazy good understanding of some endpoint thing, like whatever, this can also help diversify your experience there, right? You can work with more tech, maybe touch some things that you haven't really seen before, just generally like build a broader base of knowledge. And doing a project isn't always for learning about a specific topic, although that's usually one of the major outcomes. In my mind, it's more about learning how to learn, and you're learning how to teach yourself new things, how to grind, how to put up with frustrating bugs, that sort of thing. And most importantly, this is not a red team recruiting talk. This isn't even like targeted for red teamers. This is for students, freshmen to masters, right? And we kind of actually talked about this last night during the red team meeting, where this almost doesn't apply to the red team kids because we don't want everyone to build a C2. It's kind of just like a massive waste of cycles because we have so many pending projects. But for everyone, this can be a great thing because it's a great learning experience. And this presentation is not at all going to be like a single source of truth for C2s. It's probably not even going to help you write one, but it's just going to give you some things to think about if you're trying to write one. And like also fair warning, there's not really any content here. It's just kind of my thoughts and like why people should try writing a project like this. So we're just gonna go over what C2 is, what is command and control, why should you even try this? Why should you bother with this? We're gonna touch on some basic examples and a slightly more complex example, and then I'm just gonna talk about some general development stuff and field any questions. So what the heck is command and control? It's something that's thrown around a lot in security, probably even in classes and whatnot too. It can have a lot of subtle differences in the meaning, but basically it's distributed system administration, right? It's a single point, whether that's like a server, some specific site, whatever. There are going to have multiple endpoints reaching out to that in order to fetch instructions or fetch some kind of information. And in industry, C2, like I mentioned, can be used in a variety of contexts, right? You can maybe say like the C2 is this server, or like we're seeing C2 and you're describing the communication, or the way I'm using it in this presentation, right, is the whole system. When I say build a C2, I don't mean like build a specific API. I'm kind of talking about the whole general infrastructure. And this kind of actually bounces off what some of the stuff Emmanuel was just talking about, but some of the real world C2 examples we see can be stuff like, a malicious doc pulls some second stage payload, and that's going to execute and communicate with C2 so that you can execute commands, exfil information, whatever. And we talk about a lot of red team and blue team stuff in the club, and it's a large portion of what we miss is stuff like commodity malware, like Emotet and TrickBot and things like banking Trojans, which are super prevalent in the world. They all use C2, and it's just a slightly different context than what we talk about because we're mostly talking about, the red team has a server and they are executing lots of commands on blue team computers. But it's a little more broad than that. However, I am going to focus more on the former and more on the like academic kind of approach to this. So why should you bother with this? Why is it a good project? I think that it's a great project for all skill levels because there's a huge breadth and depth of knowledge required for something like this. If you're brand new and you don't know what you like, you can just kind of get your feet wet with each category a little bit. Maybe you don't know anything about databases, you want to try using one. Like maybe you've never even like looked at DNS, but you're really interested in like ripping apart some encoded A records and figuring out how they work. Or maybe you've only ever used Windows and you didn't see Linux until CSEC 101, and now you want to learn how systemd and package managers and all that fun stuff works. So how do you even go about something like this? Like I mentioned, there's a lot of variety of knowledge required. You're going to kind of split it up into three parts. And the first part is going to be the server. That's where you're going to hold all the data that you collect from bots. This could be command output, which is like most common for competition scenarios, or maybe in the real world, you're seeing stuff like passwords, banking data, that sort of thing. And the server is also going to track what bots you're currently controlling. Who do you have power over? What can you do? And depending on the complexity, you might have a separate database, you might use an ORM or have some fancy API and whatnot. Um, Technically, the commander I have listed here is kind of a separate part, but I'll just mention it here for brevity. It's something like a CLI or a UI that just allows you to interact with your server, queue actions, view results, that sort of thing. And the server is where you're going to spend a lot of time doing actual development if it's at all complex. And other sections might have, a lot more time reading RFCs or researching features, whereas this is going to be a lot of coding and more like software engineer design stuff, just because the reality is it takes a lot of time to come up with a good database schema and writing a lot of API endpoints. It's just something that, it's going to take a long time for you to do. Even if you know about it, you still got to write a bunch of code. The second part is the transport. That's how the client and server are actually going to be talking to each other and sending data back and forth. Mostly, you're just going to be jamming whatever you want to say into an existing protocol. Maybe if you're using DNS, you want to put it into some text records, or ICMP, you're just going to put it into the message body, whatever, stuff like that. And this, like I previously mentioned, is going to be a section that has a lot of documentation reading, right? You have to really understand how the protocol works and what normal behavior looks like for that protocol. So for instance, you know that DNS is a query and a response, right? You're not going to want to design your thing to be a single query and 700 responses, right? That stuff's just going to look weird. So there's a lot of research to be done here. And this is where classes, like net services, maybe sysadmin, stuff like that, where you can really get protocol knowledge is going to be super useful for you. And the client is going to do a lot of things, but mostly executing commands, collecting data, shipping it back to the server. There's a lot of ways to do this, and they're varying complexity. It varies by OS and by language you choose. And this is the segment where you can really dive into OS internals. So you can find out how services work. You can learn about random OS features you can abuse, like maybe bash profiles in Linux or utilman in Windows. And when I say client, I'm not just talking about a malicious binary you can run, or I'm talking about how it can be executed, how does it persist, that sort of thing. And in this context, it's just kind of a broad thing for anything going on the host. And when you're thinking about building a C2, there's a few like core questions you're going to want to mull over. And one of the one that's really important to your whole design is, will you have like bidirectional communication? Do you care about looking at output of commands, or do you want to be able to exfil data? And reliability is probably the most important thing. Like, will packet loss ruin everything? Do you have checksums, or like is a dropped packet gonna break your encoding scheme and body your server, right? And detectability is a little bit more of an advanced thing, and it's likely not something you're going to be considering if this is your first try, and that's totally okay. But just some things to think about, will your traffic blend in like I previously mentioned with the weird DNS things, or maybe you've got some huge ICMP packets and it's going to throw people off, stuff like that. And maybe your execution method is super visible, like it's just a running process that's just running as root forever, right? So things to consider that if you're trying to kind of bump it to the next level of advanced client stuff, you're going to want to really think about that. So I don't really have a fancy live demo, but we can look at some super awe-inspiring screenshots of code. And for the first example, this is it. It's like a super simple API endpoint, just reads a text file and throws the content over a web response. The client is just looping bash, right? And it's just going to execute whatever you get in your web request. This is pretty much as simple as it gets. It will work. It'll work pretty efficiently. I mean, to be honest, we even run like a slight variation of this as a red team C2, just because it's so simple and it's reliable. And it's really not that bad for like 20 lines of code total. And of course, like there's a lot of weaknesses with this, right? You can't see output of any commands. Like, sure, you can run RMRF, but You can't cat Etsy shadow. You can't really look at anything. And you also can't really target specific hosts because, there's one endpoint, right? Like there's one commands.txt file being read. So we can't really discriminate against what we want to do. And that's a pretty huge weakness because everyone is just reading from the same place. And detectability, it's a plain text HTTP request, right? And the client is just a bash script that's looping forever as root. So probably pretty detectable. A lot of room for improvement there. Reliability, though, is pretty good, right? If you have a web port that's open, this is probably not going to fail. Like HTTP, it's being sent over TCP, right? All that stuff is draft packets and whatnot are being handled by the protocol and all that. So you don't have to worry about that. The content of the file will get to the host probably. For a bit more of a complex example, we're going to talk about something that it's still going to have a web API, right? Because that's core to a server. But maybe we'd rather use a Postgres database because that's a lot more reliable and a lot better than a text file. And maybe interacting with that database is going to be annoying, so we're going to have to use an ORM. And maybe instead of a boring and non-machine friendly HTTP traffic, we want to, pack it into a custom protobuf message. And maybe we want to send that proto over more than one protocol. And maybe we also want to have an API to compile and host our payloads so that we don't have to deal with it. And maybe just to make it easier, we're going to smush it all into Docker, Compose, and we'll smack a CLI on the commander so it's easier to interact with. And there's a lot more. There's really a lot going on here. And if you're feeling a little bit overwhelmed, or maybe you didn't know all the words I just said, or you don't super understand how they're applicable here, that is totally okay. That is normal, that is expected, and nobody's probably gonna understand all that stuff right off the bat, and we'll talk about that in a minute. So what can you hope to learn from doing this? It's a really great experience because you can get experience with something like a back-end development, right? Like working with a database, working with an API, those are things you might not do in CSEC classes, with the exception of like 380. I don't even know when you take that in the current sequence. So it can be a great opportunity also to learn a new programming language, or work with a new utility, work with a new tool. You can also learn about all sorts of funky endpoint stuff, and maybe you're going to try reading more about Linux if you've only worked with Windows, or you're going to do a bit of Googling to see what you can learn about systemd. And you're just going to try and get familiar with the OS, right? So that in the future, further avenues of execution or infection that you can pursue. And just some general development notes. Like I said before, there's a lot of information to cover and understand before you can build like a crazy good C2. And you're going to be overwhelmed. You're going to be frustrated at some point. That's totally normal. The huge advantage here is that you can take baby steps in each area so that you know where you want to dig in, right? For instance, maybe by the third week of you working on this, your client is still just a looping curl statement because you couldn't care less about learning Linux, right? Maybe you decided you wanted to learn about databases and web apps, so you've spent all that time designing a schema and writing an API. That's a solid win, right? Like you're learning something that you found interesting. And if you don't find the Linux stuff super interesting, fine, ignore it and just keep the minimum in place. And if you're feeling lost or you know nothing about how do I implement protobuf, like I don't even know what that word is, or how do I write an API in Python, right? Totally fine, also expected. Between Stack Overflow, blogs, other Googling, that kind of stuff, you can learn a ton. Languages like Python, Golang, C, they have so many resources out there that you can pretty much go zero to hero just by Googling, searching online. And the whole point of this is to learn something totally new. So if you stay in your comfort zone and you're not willing to try out any new methods, like what's even the point? Right? If you know about the topic before the project, what's the point of the project? So another really important thing is that there's not really a bad time to start here, right? Even if you're pretty busy, maybe you only have an hour a week, that's fine. Just like dive in, start thinking down and jotting down ideas. Just start. Like that's the first step, and it's the hardest of any project. Once you start committing code, building out features, you're gonna build some momentum there. And another really important thing to keep in mind is this is not the be all end all project, right? Like I mentioned before, you're not going to love working on every part of it. And that's the point, right? You're going to abandon this. You're going to get bored. You're going to lose momentum and stop working on it at some point. hopefully before that happens, you are exposed to something that you do enjoy and you find something that you do want to pursue. So like maybe you've decided you only want to work on Windows services or you only want to spend your time doing funky custom network protocols, like that's fine. Finding yourself and finding a topic of interest is the whole benefit of this kind of thing. Like I've been saying, you can kind of just do a little bit of this, do a little bit of that, and see what you really like. And don't feel bad about abandoning something, right? Like I'm myself for sure. I know some other similar classmates, right? Like I probably have 100 repos in Git, and probably 20 of them actually have any substance. Because it's like you do something, you learn a few tricks, and then it's hey, I'm bored with this, and I move on. Totally fine. So I just kind of jotted down a few resources here. Um, it's not the be all end all, right? It's just some common Golang Python things, a few assorted OS specific things, and definitely don't forget that talking to your peers, asking for help in workplace, like as long as you're polite, someone's probably going to help you. And it's like getting some type of mentorship role, like what you guys have going on, is absolutely the best way to learn, in my opinion. So, yeah, definitely don't discount that. That's not to say, don't Google before you ask a question because somebody's just going to link you the "Let me Google that for you" page. But never feel like afraid to ask for help because everyone needs it at some point. Yeah, and if anyone has any questions, feel free to shoot them now or hit me up on Workplace, whatever. Um, I guess I should probably look at a chat or something. I don't know. Oh, it looks like shoot, there's a bunch. Um, Darkfile 2, how do I choose what language, database, etc. to use? Is there a best option or what are the trade-offs? So I would say it depends largely on what your goal is. Um, Stuff like MySQL, I would say for databases is super well documented, and pretty much every language has a way to interact with it. I I personally I use Postgres a lot just because the command line's like a little more familiar to me, but that really doesn't matter. The database is like pretty trivial if you have a good management system in your code. So I don't have a ton to say about that. But as far as choosing what language you want to use, there is a lot to consider there, right? Like if you only have a very basic Python knowledge because you're a brand new student, right? That's great. That's totally fine. So maybe you are going to want to pursue Python, right? Because how do you want to tackle features in a new language that you've never touched when you don't even really have a great understanding of one? Um, Once you have a good solid understanding of one program language, I think it's a lot easier to hop off to other ones. I will always simp for Golang, so I would say that's pretty much always the best option. Um, and yeah, Jorgy 7, I would never use Ruby on Rails and directly edit a text file personally.